Well, hello, pre-calc students. Obviously not ideal in that I have to stay home today with a sick child, but wanted to make sure we still got through some of the lesson items. So here's me filming a little video for you guys to explain some of the examples that you can work through today while I am gone. So this is continuing lesson 11.1, limits in motion, the tangent problem. Yesterday we looked at the definition of derivative at a point two different ways. So we had f prime of a, the derivative of function f at a is equal to the limit as x approaches a of the difference quotient f of x minus f of a over x minus a. Remember, this is like the regular old slope formula. Now, we also talked about this alternative definition, which again, in calculus, we use this more, in my opinion. So I like this one better, and this is the formula that I'm going to use. F prime of a is equal to, limit as h approaches 0 of f of a plus h minus f of a all over h. And we did a little diagram yesterday to explain what that is. And then we did an example where we had 3t minus 5, and we wanted to find the instantaneous velocity, or the derivative or slope at t equals 4. So that's what we did. We used the limit of the difference quotient, plugged in 4 plus h, because that's 4 is the value where I want it to be. So 4 is like the a in the formula from up above. So the f of 4 plus h minus the f of 4. So plug in 4 plus h, plug in 4, subtract what you get. A bunch of stuff kind of cleaned itself up and went away algebraically. We ended up with the limit as h approaches 0 of 3 was 3. So that was our slope, or our instantaneous velocity, or our slope of a tangent line at that point. So now examples 4, 5, and 6, a little bit tougher, but it's the same process. I'm going to walk you through. I've already written them out, so I'll just pull this up so you can see it, and I'm going to kind of talk you through line by line what's going on here, okay? So number 4 in the examples, s of t was equal to 2 over t plus 1, and we're supposed to find the instantaneous velocity, or the derivative, at 2. So the s prime of 2 is what we're after. Ignore my blue marker, it was too thick. So we start by finding the limit as h approaches 0 of the s of 2 plus h minus the s of 2. So this is, again, in the formula in the notes, f of a plus h minus f of a. F is changed to s because s is the function we're working with. A is 2 because that's the value at which we're finding this derivative or slope. Now, I plug in 2 plus h into the function. So 2 over 2 plus h plus 1, right there. Minus, plug in 2 into the function, 2 over 2 plus 1. So 2 over 2 plus 1 is here. So again, I just have, this is me, this line is just me plugging in 2 plus h and plugging in 2 into the function. The next line of text right here is me cleaning up this expression. 2 plus h plus 1 turns into 3 plus h. 2 plus 1 turns into 3. So now I have this fraction right here. S prime of 2 equals the limit as h approaches 0 of 2 over 3 plus h minus 2 over 3, all of it divided by h. The next step, I'm going to take these two rational expressions, these two fractions, and combine them over a like denominator. That's what you see happening over here. I multiply this fraction by 3 over 3. I multiply this fraction by 3 plus h over 3 plus h, which gives me a common denominator of 3 times 3 plus h. The 2 over here gets multiplied by 3. This negative 2 gets multiplied by 3 plus h. All of this fraction is still over h. Next line. I take 2 times 3 and get 6. I take the negative 2 and distribute it to get negative 6 and negative 2h. I distribute the denominator as well, so I have 3 times 3 is 9, plus 3 times h is 3h. This is all over h still. Still find the limit of this as h approaches 0. Then, if you clean up this algebraic expression, 6 minus 6 is 0. It's gone. Negative 2h over 9 plus 3h. Now, instead of dividing by a fraction, dividing by h, I will multiply by the reciprocal instead. Again, this is just good old algebra stuff dealing with rational expressions. Hopefully you've learned that well enough at this point to be okay with this. Then, multiplying two fractions together, I can cancel common factors like an h. This h and that h will cancel, which gives me the expression you see right here. Negative 2 is all that's left in the numerator. 9 plus 3h is in the denominator. I'm going to then find the limit of this expression as h approaches 0. And again, at this point, h being 0, like I can find this limit by direct substitution. Take 0 and plug it in for h and see what you get. Way back at the beginning, if we had plugged in 0 for h, we would have had division by 0, which you cannot do. Breaking the first commandment of math, can't do that. So now the 0 goes in for the h down here. 3 times 0 is 0, it's not there. Negative 2 divided by 9 is negative 2/9. Negative 2/9 is the s prime of 2. Negative 2/9 would be the slope of the tangent line at that point. It would be the instantaneous velocity if this is a position and velocity function that we're working with. So I found the derivative, okay, using the limit of the difference quotient. A lot of algebra work here. Now, the good thing is, at some point in calculus, we learned some tricks that make this process go a little bit faster. But we have to do this and understand where it comes from before you get to learn those tricks. So, too bad, you just got to deal with it. And know, hey, if I'm taking calculus, this is the kind of work that I have to be comfortable with. If you're not comfortable with it, don't take calculus. You probably don't need it. Scrolling down to number 5. So again, same deal. Find the instantaneous velocity at t equals 2. Our function is now a times t squared plus 5, where a is some constant multiple. So same process. S prime of 2 is the limit as h approaches 0 of the s of 2 plus h minus the s of 2 all over h. 2 plus h gets plugged in for t. There you go. A times 2 plus h squared plus 5. 2 gets plugged in for t. There we go. A times 2 squared plus 5. Algebra cleanup time. 2 plus h gets squared, turns into 4 plus 4h plus h squared. There's still the a there. There's still plus 5 there. 2 squared is 4 times a is 4a. Distribute the negative 1. We get negative 4a minus 5. Now, I do some algebra in my head here for the next step. I take the a and distribute it. A times 4 is 4a. Minus this 4a, it will go away. It's not there anymore. It's 0. By the way, this plus 5 and this minus 5 will also cancel. They're not there anymore. Okay. This a times 4h is 4ah. You see it right here. A times h squared is ah squared. You see it right here. So I got 4ah plus ah squared all over h. Still finding the limit of this expression as h approaches 0. But again, I'm doing all this algebra work so that I can clean up this expression. Now here, dividing both of these terms by h, this h cancels, one of these h's cancels, and gives me the expression you see over here, 4a plus ah. Now, find the limit of that expression as h approaches 0. A times 0 is 0. This part of it goes away, and we are left with 4 times a. So again, a is some constant multiple. I don't know what it is. It doesn't matter. 4 times that multiple, whatever it is, will be the slope at that point. It will be the derivative at 2. It will be the instantaneous velocity at 2. One more example. Number 6, a square root. So again, this one, I use what I would call the alternative definition, but actually it's the one that your textbook, our pre-calc book, gives to us first. So real quick, take a peek. We're using this formula up here. F prime of a is equal to the limit as x approaches a of f of x minus f of a over x minus a. Okay, so this is the formula I'm using for number 6 because it works out well with the square root and because I wanted to show an example of the other version of it. Real quick, here we go. Step 1, I'm finding the limit as t approaches 1 of s of t minus s of 1 over t minus 1. And again, if you're looking at the formula in your notes going, what the heck is he talking about? S is f, because s is the name of the function. T is x, because t is the independent variable. Okay. A is 1, because that's the value at which we're finding this derivative or slope. Okay. Now, the s of t is this function right here, the square root of t plus 1. The s of 1 means take 1 and plug it in for t. 1 plus 1 is 2. The square root of 2 is the square root of 2. There it is. The denominator is just t minus 1. Great. So here I am. This is my derivative at the moment. If I plug in 1 to find the limit, 1 plus 1 is 2. The square root of 2 minus the square root of 2 is 0. Neat. Divided by, 1 minus 1 is also 0. Shoot. So 0 divided by 0 doesn't exist. I got to do some algebra work. Now, the weird thing with radicals is that we're actually going to make it what you might think is a bit more messy. If I have a radical like this one in the numerator, I will rationalize the numerator. It says that in your notes as a little hint here. To rationalize it means to multiply this expression by its conjugate. So you'll notice on the next line, I take this difference of radical expressions, times its conjugate, which is the same two radical expressions with a plus sign in the middle. And if I multiply the top by something, I multiply the bottom by that something as well. Now, multiplying these numerators together. The square root of t plus 1 times itself is t plus 1. Nice, huh? The square root of 2 times itself is 2. It's negative because it was negative times positive. And note that when you multiply the outer and the inner together, they will cancel and become 0. Thus, it's not there anymore. That's the beauty of the conjugate, okay? In the denominator, I could have distributed, but I don't want to, and here's why. I leave it as t minus 1 times that weird radical expression, and I apologize for forgetting to put the end of the parentheses right here, okay? Hopefully my little mouse will suffice. Now, when I clean up the numerator, t plus 1 minus 2 is the same as t minus 1. And notice I got t minus 1 over t minus 1. How cool is that? It's a product, so I can cancel common factors. T minus 1 divided by t minus 1 is 1. That's not there anymore. Now there's just a 1 in the numerator over a denominator of the square root of t plus 1 plus the square root of 2. At this point, to evaluate the limit of this expression, I take the 1 and I plug it in for t, because it's not going to give me 0 in the denominator anymore. You plug in 1 as we get down here. Here we go, plugging in 1. 1 plus 1 is 2, so I have the square root of 2 plus the square root of 2. Well, that's 2 square roots of 2. 1 over 2 square root of 2. That would be my final answer. That is the derivative at 1. That's the instantaneous velocity at 1. It's the slope of the tangent line at 1. It's the derivative at that point. So hopefully that makes a little bit of sense. I know it was fast, but I'll post this. You can read through it, and hopefully my explanations, if you need to just slow it down and watch it at like quarter speed or something, you'll be okay.